Today is Wednesday, day 17, and we are going to talk about some different kinds of functions. This is in 10.3, and I'm going to go ahead and show you all of my notes in case you want to freeze it and write it down, and then I'm going to zoom into each section. Okay, so the first part is talking about absolute value, and absolute value, all you really need to know is whenever you see those lines, it's talking about absolute value, and then absolute values are going to be V's, or they can reflect, and it can also be an upside down V. And that V can be anywhere on the paper or upside down anywhere on the paper. And then you have quadratics, which we know lots about, and those look more like U's. They can be skinnier and wider and be shifted up and down and left and right and reflected as well. And then we have exponential functions that kind of go up like that. And then we've also just done some lessons on square roots and cube roots. So let's look at this first one, this absolute value function. The domain here would be all real numbers because it's going out, 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 out everywhere. The range is, it's never going to be down here on this particular one. So this particular absolute value function would be y is greater than or equal to 0. There is a minimum value. So on these questions, it basically asks, is there a min or a max? Like yes or no, because sometimes there's not a min or a max. So yes, this one actually has a minimum, but most of these questions are just going to want to know, do they have a max or min or no max or min? And then is there an axis of symmetry? Yes, because I can fold it over. Okay, so let's move over to the next one, this quadratic. Domain, all real numbers. The range is y is greater than or equal to 0. Is there a max or a min? Yes, there's a minimum. There's no max because these are going to go up forever. There is an axis of symmetry. When I look at an exponential function, it is all real numbers. Now, an exponential function, this thing can get closer and closer and closer and closer to 0, but never cross the 0 line. So this is also going to be just y is greater than 0 because it's never going to touch 0 in this particular function. And sometimes that can happen if I had a few more numbers, it can happen over here too, where it's going to tailor off and never touch one of the numbers. Is there a max or a min? No, there isn't a max or a min. It can keep getting smaller and smaller and smaller and bigger and bigger and bigger. Is there an axis of symmetry? No, there's not. Okay, so what I want you to do is be able to kind of picture what those graphs look like in your head. And then if you look at this question, it says, does it have a max or min? That's all we care about. Is it the kind of graph that would have a maximum or minimum? We don't need to know which one, just yes or no, it has one or not. So if we look at the first one, you're just saying to yourself, well, what kind of graph is this? It has an exponent of 2, so we know it's quadratic, so yes. We also know that because this a is positive, it's going to look like this. So we know it's going to have a minimum, but they're not even asking us that. Here we have a square root function. So if you remember from your square root functions that look kind of like this, it does have a minimum point. Once again, not asking what it is. Here we have a cube root function. So remember, remember your cube root functions look like this, and they were going to go on and on and on forever in both directions. So it does not have a minimum or a max. And here's an absolute value one. We know it's going to be like this or like this, so it will have a minimum or maximum. And the very last part of this is just asking, does it have a axis of symmetry? Actually, this isn't the last part, but the next part's kind of cool. Okay, does this have an axis of symmetry? Well, this is an exponential function, so no. This is a cubic function. So even though you get tempted to say yes, because these are symmetrical as well, it doesn't have a line of symmetry. If I were to cut it here and reflect it, it wouldn't mirror itself. You know, this would be over here and that would be there. So no. This is a quadratic. Quadratics are very symmetrical. It does have an axis of symmetry, and so do absolute values. Okay. What I think is really cool about this lesson is it's going to ask you about end behaviors. And I'm going to try to show you what my paper looks like. I did a bunch of notes up there, and I was like, I didn't like it. So if you look at that, and then I'm going to zoom in to even. Okay, so here's what this is talking about. If you have an even exponent, so if the largest exponent in a problem is quadratic, it's a 2, it's even, if this number here is even, then we know something about the end behavior. We know that they're going to be going in the same direction. So, you know, if this was a 4, then it might be like this. But we know the ends are going to be going in the same direction. So if it's even, the ends are either both pointing up or they're both pointing down. Whatever. We know that if it's even, it's pointing both the same direction. Now, to figure out if it's going up or down, if the A is positive, just like what we did before, if the A was positive, it was a smiley face, they were going up. The ends were going up. Same thing here. If this was a 4 and the A was positive, it would be going up. And if the A was negative, they'd both be going down. Okay, so even number tells you same direction, and if the A is positive, they're going up. If the A is negative, they're going down. All right, so let's talk about what if it's odd. What if you have something cubic, if it's odd? Well, now, like what we did earlier, these are going to be opposite directions. All right, and what I should have done is done this one first. Here, sorry. Okay. So if it's odd, even if it's a 5 or a 9, you know these are going to be going in opposite directions. And if A is positive, you know, even something that looks like this, you know that the exponent's going to be odd. It would go like in a positive slope, like you would start down and then go up, okay, like that way. And if A is negative, it's the opposite. Signs are going opposite, and it's more of like a negative slope. So that's how you figure out the end behaviors. So on a multiple choice test, if I asked you to match the graph with the equation, you could just look at the exponent and it would tell you, and the coefficient of x cubed or whatever the A is, and it would tell you, you know, which way the graph would look like. Okay?